Anyway, you all ready?
Yeah, we are.
Without further ado, Quentin and Will are going to wow you for the next 45 minutes. So let's give it up for them.
Thank you. Hi, everyone. Welcome to our talk, Turning Your Active Directory into the Attacker C2. Short as not that bad. Today, we'll talk about group policy, object enumeration, and exploitation. Let's first introduce ourselves. My name is Wilfried. I'm with my colleague Quentin, or Quentin in French. We do pen tests and red team at Synactive, and this is the first time for us at DEF CON. So let's start by a quick introduction. During an assessment, one of our colleagues said, well, yeah, we have an account that can modify a GPO that applies to domain controllers, but let us check for the ADCS first. So they enumerate ADCS, they find out they can exploit ESC4, which is a privilege escalation. They exploited it successfully, but at the end, they got detected. So now we always mess up with them, like next time, maybe don't go straight for ADCS and look at GPO. So this is why we are talking about GPO today. Group policy object attack vectors may just be the ugly ducklings of AD exploitation. Why? Maybe it's not well known, maybe it's too risky to exploit, because you can mess up Active Directory. Maybe there's not enough tooling. So we think it's a shame because attackers don't have such concern. And also GPO exploitation can be quite powerful because you can manage a lot of things into the Active Directory. So today we're gonna give you a brief recap on how GPO works, how they are implemented, and we will list 4 tools that will show that we can enumerate them and also exploit them with different kind of parts. Okay, so let's start by explaining group policy objects. A GPO is a collection of misconfiguration that applies to AD objects. It's a core feature of Active Directory. It deals with device and identity management. And a GPO can define user settings and computer settings. I'll get into the details of that later. When you want to configure GPOs, you can open the Group Policy Management console. And GPO are not applied directly to user and computers, but most of the time to organizational units. They can be also applied to different objects such as sites or domains, but is less common. Something important to mention is like when you define settings through GPOs, by default GPO will inherit from the parent container. For instance, here, the default domain policy will apply to all child containers, all child organizational units, such as, for instance, here, workstation, servers, and so on. The implementation of GPO in Active Directory is a bit specific. They are basically made of 2 components. The first one will be the group policy container, which is an LDAP object. You will find GPO metadata, name, description, version, and so on. I will give some specific details after. You will also find the group policy template, which is a SMB share that will contain the GPO files that describe the configuration that will be applied by the clients. So what you have to remember is basically you have 2 components, the LDAP parts and the SMB parts, as are tied together by a specific unique identifier, the GUID. And basically the LDAP part say where the GPO applies, and the SMB part say, okay, the GPO does these specific settings. Okay, so let's try to go into the details of the first part, everything regarding the LDAP. There are some noteworthy LDAP attributes, such as on GPC objects, the GPC file sys path. It will indicate where the UNC path of the GPT, so the SMB part, where the GPO file is located. You also have more attributes such as flags that will say the status of the user or computer configuration. It might be enable or disable. I will move on that later. We also have specific LDAP attributes on organizational units. For instance, the GP link, it will say if the GPO is linked to this organizational unit. It can also be enforced. And you have also options such as inheritance. And the other part, the SMB part, was the group policy template. So in the SMB share, you have multiple configuration files, such as group.xml, receipt.xml, and so on, when you can specify those settings. If I take a quick example, on the bottom, you say groups.xml, which is where you can assign group assignments. Here we can see that the user Jack is added to the remote desktop user group. Okay, so this is the basics. So now let's go into the details of the attributes. First, we will talk about inheritance on organizational units. I mentioned previously that by default, GPO will be inherited on the child containers. What you can do is you can avoid this by blocking inheritance. And when you go on the management console, right-click on the workstation, on the organizational units, you can block inheritance. And what's the change? On the LDAP, you have the GP option that will switch from 0 to 1, and it will be 1 if inheritance is blocked. And when you do that, any parent GPO will not apply to the specific organizational units. We also have the link attributes. So GPO are linked to organizational unit, like I mentioned earlier, and this is done by the GP link attributes. You will find in the specific attribute the command name of the GPO, and at the end you will find an integer that will describe the link status. This integer may vary from 0 to 3, and it will say if the GPO is linked, unforced, and so on. And if the GPO, for instance, is unforced, it will ignore the inheritance status. Here we have the table that said the configuration. Most of the time you will find out that the integer value will be 0, but we can also see unforced GPO, so we'll find the integer value of 2. Move on to other attributes. Now it's related to GPOs. So I mentioned earlier that GPO can apply to user or computer configuration, and you can change it with the specific flags. So you can enable everything, which is the default. You can also choose to apply only computer or user settings, and you can also choose to disable everything. And what's going on behind the scene is we have a specific attribute, again, on the GPO object, which is called the flags, and we have an integer that will describe which component is enabled. So the integer, by default, the integer value will be 0, so basically computer and user configuration are both applied, but we can see sometimes it's, for instance, if the integer value is 1, only computer settings are applied. Last part regarding GPO implementation is we have, by default, the computers updates their GPO. They're doing a background update every 90 minutes with a random offset from 0 to 30 minutes. This setting can be changed. On each GPO, you can change the settings and put the value of 0. And the documentation, if the value is 0, it will try to update the GPO every 7 seconds. I would not recommend to update your GPO every 7 seconds, but it's technically possible. And so another thing to mention is not all policies are proceed. For instance, software installation will be only applied when the computer starts, or there are also specific GPO that are triggered when the user logs on the computer. So now how the computers update its GPOs. So first, it interacts with the domain controller, querying for the LDAP for specific attributes to know what are the GPO tied to the specific computers. It queries the attributes such as GP link or GP option that I mentioned earlier. And now the computer have a list of which GPO applies. Then it queries the LDAP again for more information, such as GP file syspath. So now the computers know where the files are located, where the SMB share. By default, it will be on the domain controllers in the sysvol share. It also retrieves all the information such as flag, is computer or user or computer configuration are enabled or not. And now, because it has all information regarding the LDAP, it initiates the SMB connection, and it retrieves all the file and applies the GPO. Okay, so this was how GPO works. There's also few other attributes that we don't have time to talk about, but these are the main important one. So now we want to present you a tool that we developed when we want to enumerate GPOs and also doing a stealthy way. We find out that during assessment, GPO enumeration is quite useful. It reveals valuable insights into the security posture of the system. And most of the time, we will see interesting stuff like group membership or addition, privilege assignment, registry modification, and so on. So it's quite interesting from an offensive perspective, and we go into the detail of each one. The first one will be, the most common one will be group memberships. Group memberships are frequently defined through GPO. Information that can prove crucial for lateral movement. For instance, I want to perform lateral movements, but I have a specific account. I don't want to try this specific account on every computer. It's quite noisy. I don't want to perform wide range scans, such as using netexec on large ranges. So by enumerating this through GPO, I know exactly where this specific user has administrative privilege rights or where it can do on specific computers. So I have a better understanding of group assignments. So let's do an example. Here I'm calling the LDAP with a tool that is called LDIP, and I'll try to enumerate all the GPO. The first one is called Allow LGP. This is quite interesting for us because I want to perform lateral movement. And this is also something that we already seen during our assessment. So I'm interested in for this specific one. I'm looking at this specific unique ID identifier, which starts with 008. And then I go to the domain controller on the sysvol share, and I try to retrieve all the files dedicated to this specific GPO. And within those files, I find out there's a group.xml file that says basically the group domain user is added to the remote desktop user group. So I know this GPO is adding domain user to remote desktop. Now I need to find out where, on which computer. So like I mentioned earlier, by default most of the time GPO are linked to organizational units. So again, I try to enumerate all the organizational units, and I can see here that my GPO allow LGP is tied to workstation organizational units. Next step is to find out which computer is within this organizational unit, and here we have the wks01corp.com. So now if I type everything together, I can know that the domain user group can RGP on the workstation1corp.com. So now I can move laterally easily without doing any noise. I want to be stealthy, so it's better to enumerate GPOs. What you can do also is privilege assignments. You can assign interesting privilege through GPO. For instance, you can assign the SE debug privilege, which allows us to debug any processes that you do not own, and it can be a free privilege escalation. We found out this is relatively uncommon, but still possible. But in reality, it happens. Here we have a practical example that the SETCB privilege has been assigned to any user on the machine. And basically, it's a free privilege escalation. With this specific privilege, you can add arbitrary groups to your token, such as administrator, and compromise the computer. What we see most of the time will be connection restriction. When you don't want your domain admin to connect anywhere in order to reduce the risk of credential exposure, you can perform connection restriction through GPOs, and basically they will deny access to specific computers. So it mitigates privilege escalation and try to preserve the tiering model. So when you're performing this kind of enumeration, you know, for instance, that domain admin will never connect to specific workstation or specific machine tied to organizational unit. So there's no point to go there and waiting for domain admin. You can also perform registry modification through GPOs. Legacy name resolution protocols such as LMNR, MDNS, and BNS are relatively good exploitation vectors. It has been exploited since a long time with tools such as Responder. And administrator disable those protocols through GPOs. Here we can see that the MDNS protocol has been disabled through GPOs. So by doing this kind of reconnaissance, I know that there's no point to exploit it on those specific machines. So it helps me to choose a relevant attack. Through GPO, you can also gather more information. For instance, you can go through hardening process. You can see that, for instance, LDAP or SMB signature has been enforced on which computer. You can also, so it helps you to choose if relay attacks will be relevant or not. You can also, we often see credential hardening. For instance, the registry key such as run SPPL and credential guard has been enabled. You can get more information regarding additional software installation, such as EDR, so you know what you're dealing with. At the end, GPO enumeration can be time-consuming and quite complex because there's a lot of things to take into consideration. You have to check for inheritance, you have to check for enforced link or not. You have to check if computer or user configuration is enabled or disabled. There's also more specific filters, so we have to automate this. There's a lot of tools that try to enumerate group policy objects, such as a well-known bloodhound, but we notice that it doesn't take every parameter into account. Here, I have an example where within my workstation organizational unit, I have a child container, admin, and admin on the admin container, the organizational unit, the inheritance is blocked. I'm using the same GPO, allow RGP, that I mentioned previously, which allow any domain user to connect on those machines. So I have a workstation 1, which is within the admin container, and the inheritance is blocked. And the GPO allow RGP is on the workstation organizational unit. So basically, it prevents any user to connect to my workstation admin. On the right, you have a PowerShell command. When I update my GPOs and I enumerate the members of the remote desktop user group. And when the GPOs are successfully updated, I can see there's no members, which is quite normal because inheritance has been disabled. And then when I collect the data with Bloodhound and I ingest it, Bloodhound forget to take into consideration that the inheritance has been blocked on the admin container, and it shows a path from domain user to workstation 1 with the can RGP edge, which is false. So we notice there's other tools, but they also don't take every parameter into consideration. So we develop a tool which is called GPO parser, that we parse all GPO configuration parameters that presented earlier. It tries to reveal misconfiguration and privilege relationships. It supports both online and offline analysis. And we try to enrich Bloodhound with useful edge. This way we can create the new edges that we have lost from our GPO collection, such as admin2, can RGP, can PS remote. You will find the tool on the Synactive GitHub right after the talk. So I will give you a quick demo of this one. First, we will try to collect it. We will collect it. Sorry, the wrong demo. I will first show the demo that goes online. Okay, so basically you have to. Here I'm doing the collection remotely. You can collect GPO with a low privilege user. So I'm specifying the credential. I'm specifying the LDAP and also the domain controller. It tries to connect, retrieve all the file, and it parse. And here we can see, for instance, this specific GPO, which is called enforced SMB signing, has been applied. You can see there's some specific connection restriction tied to domain admin. You can also assign privilege, for instance, SE debug privilege to the developer groups, and so on. For instance, you can see that the group, all admin, all our workstation are workstation admins. You can also perform this reconnaissance offline. So what you have to do is you have to collect all the LDAP data. I will do this with LDIP, collect few information regarding the LDAP. I will also need to retrieve the policy, which are by default on the sysvol share. I'm retrieving everything here. We can retrieve all the needed files, but here for the presentation, I'll just retrieve everything. And I will pass it locally. So I have to specify where I find the sysvol share and the LDAP folder. And what I also want to mention here, like we can also filter. For instance, we want to know the GPO that's only applied to a specific target. For instance, the specific computer workstation 1. And here, locally, I can see that all the GPO that are applied to this specific workstation, and now I can see the same information, but tied to this specific workstation. So basically, it's the same. You can see that domain user can connect through a remote desktop user group. Now I will let my colleague Quentin speak about abusing ACLs.
All right, thank you, Wilfried. So Wilfried explained to you how GPOs are implemented and how you can abuse them to enumerate some security-relevant configurations. For my part, I will actually explain to you how we can abuse group policy objects in order to compromise Active Directory objects, so users and computers. And the first way I'm going to do that is with the most standard way you would exploit a GPO in an Active Directory engagement. So let's say you have write access to a GPO with a user. And this is not an uncommon situation. We encounter it pretty often in engagements. This can be T1 accounts. This can result from administration mistakes, etc. And this is actually a very powerful primitive, attack primitive, because when you control a GPO, you can compromise all the objects that are linked, that are included in all linked organizational units, including sub-OS. When you exploit a GPO, what you basically want to do is just leverage some built-in GPO features in order to deploy malicious configurations to the users and computers to which the GPO applies. And you can really deploy a lot of malicious configurations. You can deploy some scheduled task, you can deploy some immediate task, or you can do something like add a user to a local group, you can transfer files, execute files, setting registry keys, you can define some logon or logoff scripts. What I want to point out is that imagination is really your only limit when you want to exploit a GPO in order to compromise the objects to which it applies. And we have some offensive tooling to exploit GPOs, not so many. We can have something like sharp GPO abuse, PyGPO abuse, GPOs, or the DRSIT tool suite. But during engagements, we found out that these tools have some limitations that made them pretty difficult to exploit. The main one is the stability and exploit safety consideration. So GPOs are very critical in Active Directory. They are sensitive architecture components, so you really don't want to screw them up. So exploit safety is really important. There was also some lacking in cleanup and revert capabilities. After we exploited, we want to clean up for stealth or just to clean up after yourself. Very often, there was no possibility to create GPOs, to manage links, to target specific objects with your malicious configurations. And more generally, there was a lack of available actions and options that you could configure to exploit your GPO. So we created the group policy backdoor.py tool. This is a Python implementation using only LDAP3 and SMB protocol, so no impact for stealth considerations. You can do quite a bunch of things with group policy backdoor. You can create your GPOs, delete them, backup them. You can manage your links. You can inject some customizable configurations. Importantly, you can also leverage the item level targeting feature of GPOs in order to only inject your configuration to specific objects. So if you want to target a specific computer, you can with group policy backdoor. You can also clean up after yourself and revert the actions you performed on clients. So it will be available on GitHub after DevCon. For it to be a little bit more concrete, let's take a real-world example that we encountered like a few months ago. And let's try to exploit it with group policy backdoor. So we compromised an account a few months back that had write privileges over a pretty interesting GPO because the GPO was applying to a jump server that was used by domain administrators in order to perform some administrative actions. We did not have any kind of privilege other than the rights on the GPO. We did not even have network access to this jump server. But what we did was that we exploited the GPO in order to add a scheduled task on this jump server. We configured this scheduled task to run in a privileged context using the identity of a domain admin, and the scheduled task only added an account under our control to the domain admins group. And you can see here a pretty interesting thing is that we are exploiting a GPO that applies to a jump server in order to, so to say, trap the jump server so that the scheduled task will trigger when the domain admin connects to it. All right, let's see a quick demo. All right, it's this one. I think it's coming. All right. So let's say that we compromise the user that is called Alloy. You can see here I'm authenticated with Kerberos with Alloy. Alloy has some standard groups. You can see here I named the groups. It is part of the IT support group, quite standard. Let's choose group policy backdoor first to enumerate the GPOs of the domain with the enum list GPOs command. You can see there is a bunch of GPOs. The one that interests us is called jump servers hardening. let's use group policy backdoor to get some more details on this GPO with the GPO details command. All right. The most important thing that we notice is that our current user Alloy has write permission over this GPO. This is pretty good. This means that we will be able to exploit it. And this GPO is tied to an organizational unit that is called jump servers. In this jump servers organizational unit, we have the jump server that we are trying to compromise. As you can see here, the AD01 Bastion, which is the jump server that we are trying to exploit. All right, so let's inject our malicious schedule task into the jump server. In order to do that, with group policy backdoor, you define a configuration through an .ini file that specifies what configuration you want to inject into the GPO and what option you want to configure your malicious configuration with. So you can see here, quite standard. We want to inject a scheduled task. We wanted to run the cmd.exe program. We wanted to add our user Alloy to the domain admins group. We want to impersonate ADM Roland, which is a domain admin that connects to the jump server. And we want to repeat this scheduled task every minute because we don't want to wait. Additionally, you can provide some filters. Here I say I only want the scheduled task to be defined on the AD01 bastion.com computer and not on anything else, for stealth, for instance. And you just provide a filter with a computer name title. So let's run group policy backdoor with this configuration file, and this will inject our malicious schedule task into the GPO. You can see here we provide the modify commands, and we provide the .ini file that I just showed to the jump server's hardening GPO on which we have write access. So we execute group policy backdoor. It does a bunch of stuff. I won't go into details, but it modifies the group policy container. It modifies the group policy template in order to inject your configuration. It also bumps the GPO version so that clients will actually update the GPO. And now, all we have to do is, we can see on the domain controller here that the jump server's hardening GPO defined the scheduled task with the group policy management console, just for illustration. So you can see here our scheduled task is there. It is configured to run with a trigger, with an action that adds our user to domain admin, some item level targeting in order to only be defined on the Bastion. All right. So at this point, we would just wait for the Bastion to refresh its GPOs, define the scheduled task, and then add our user to the domain admins group. So that's what we're going to do. We will force the GPO refresh with GPO update because we don't have time to wait for 90 minutes. So yeah, the GPO update command is executed. And you can see right after that our scheduled task will be defined on the jump server. And then the domain admin ADM Roland will execute it and add our user to the domain admins group. You can see here we have the scheduled task defined, running as ADM Roland. And then it's all set. We just have to wait 1 minute and our user will be actually added to the domain admins group. So I just cut the minute out, but you can see here with an ldip command that Alloy is now part of the domain admins group. All right, so you did your exploitation, that's great. What you want to do then is clean up after yourself. You want to remove this configuration you injected into the GPO. And group policy backdoor makes it pretty easy because each time it runs, it creates a state folder that has many information about what it did. And you just have to provide this state folder to the clean command in order to clean up after yourself and to remove the configuration that you injected from the GPO. So you can see here, I provide the state folder into the clean command, I execute the command, and it just, again, does a bunch of stuff. I won't go into details, but just removes the configuration from the GPO. All right. So that was, I mean, we have a lot more examples of how we exploited GPOs during engagements. We used it to reach some network isolated workstations that we could not even pivot to. We used it to enable WinRM and add some firewall exceptions. We also used it to persist in the Active Directory environment after detection. So the good news is that you can just extend group policy backdoor to your use cases to add some more configurations that you want to inject into GPOs. You can do this pretty easily, so don't hesitate to do so. All right, so this was kind of the standard GPO exploitation vector. We are going to dig a little bit deeper, and we're going to see how we can exploit group policy objects via NTLM relaying. A little a little context about this research. We were, during an engagement, we were able to perform some NTLM relaying to the LDAP service, which is often the case. For instance, you are able to relay HTTP to LDAP, right, in default configurations. And we were able to relay an interesting user that had write privileges over an interesting GPO, and this GPO applied to domain controllers. So because we were relaying to the LDAP service, we had the possibility to modify the group policy container via LDAP, if you remember what Wilfried explains. But we had absolutely no privileges over the SMB share, the group policy templates, on which the GPO configuration files are located. And we were wondering, is this even exploitable? And it turns out that yes, it is, because Wilfried mentioned it also a little bit earlier, but in the group policy container, you have an interesting attribute that is called the GPC file syspath. And it specifies the location of the group policy template as a UNC path. And by default, this will be simply the sysvol share, right? But it is actually possible to specify an arbitrary SMB share location in this attribute. Anything goes. And for Microsoft, this is a legitimate feature, this is expected, but not so much because it crashes the group policy management console. So I guess this is kind of a gray area. So you can see here, I just modify in Windows the GPC file syspath to a random IP address, right? And after 90 minutes, I start to see some objects that are trying to actually authenticate to me in order to fetch the GPT files. So you can just specify anything in the GPC file syspath attribute. And so if you pay attention, we now have an attack vector that you can implement through only NTLM relaying by only modifying the group policy container. The first two steps are pretty standard, so you relay your user to the LDAP service, you interact with the LDAP service as the user. The next step is to modify the GPC file syspath to point to your server. You say basically, yeah, the group policy template is on my machine. You implement an SMB server on your machine that serves malicious group policy template files, for instance, defining a scheduled task that you want to run on the victim. And now you just wait for the object to try to apply the GPO, realize that the configuration files are on your system, and fetch the files on your system, and it will work. So we created a tool that is already available that is called GPO DT, and that does just that. I also won't go into details, but there was a main implementation challenge was to implement a working domain joined SMB server, because you can't just provide anonymous access to the objects. They will refuse, modern Windows SMB clients will refuse to actually connect anonymously to a server. So GPO DT performs some net logon to overcome this difficulty. All right, time for another demo with the GPO DT tool. All right. So we have a domain. We have the domain controller's organizational unit with a GPO that applies to it, which is the DC Corp hardening group policy object, which is a standard group policy object. You have the GUID here. But what is interesting is that the ADOV user has some rights over this GPO. And let's say that we relayed the ADOV user to the LDAP service. We can see here I've spinned off my NTLM relay X, and I relay this user to the LDAP service. And I am interacting with the LDAP service as the ADOV user. Pretty standard. So I spin off the in-packet LDAP shell in order to execute LDAP commands as the ADOV user. To be a little bit more comfortable, I will create a machine account with this LDAP shell that is called GPO DT, and I will give all the rights over the group policy container for this machine account with the LDAP shell. So now I'm in a situation that I described earlier, that is to say the GPO DT account has privileges over the group policy container, but nothing over the group policy template, and we'll try to exploit this. We'll try to exploit this to add a local admin to the domain controller, and more specifically, we'll add the GPO DT machine account that we created to the local admin group of the domain controller. We can see first that our GPO DT account is not yet part of the domain of the local admin group of the domain controller with an SMB client command. You can see here I tried to connect to the $C share with GPO DT. I got an access denied. This is quite expected. Now let's exploit this situation with GPO DT. So the command will look something like this. You specify the GUID of the GPO you want to exploit. You specify the username and password of the user that has rights over the group policy container via LDAP. You specify the command that you want to execute. Here I want to add my GPO DT computer account to the local admin group of the domain controller. And then you just press enter. Group policy GPODT will do a lot of things, but the most important thing is that it will modify the GPC file sparse attribute to my attacker machine, as you can see here. And now I just have to wait for the domain controller to update their GPOs and fetch the GPT files on my machine. And you can see on the right, I just execute GPO update. And as soon as I execute GPO update, I have the domain controller trying to authenticate to me to fetch the GPT files, right? And I authenticate it with netlogon, and I provide the malicious GPT files to the domain controller. And it will execute my immediate task that adds my GPODT machine account to the local admin group of the domain controller. As you can see, then now I can SMB client into the $C share of the domain controller. So yeah, I am local admin of the domain controller, which is good news. Thanks. All right, last part. We'll dig even deeper, and it will be the last part. For this section, we'll try to exploit protected organizational units by poisoning the GPO link attribute. A little bit of context. Wilfried explained to you that GPOs are linked right to organizational units through the GP link attribute. That looks something like what I put on the slide. And when you have write access to an organizational unit, Petros Koutroumpis showed a few years back that it is possible to add a GP link item in order to simulate a malicious GPO that objects of the organizational unit would try to apply. And why is it interesting? It is interesting in comparison with other organizational units attack vector that we previously have. So previously we only had one attack vector that was targeting organizational units that relied on ACL inheritance. And what you did was basically to add a generic role, for instance, ACL, to the organizational unit container, and it was by default inherited by all the objects of the OU, which was quite neat and simple and also reliable. But this attack vector had some pretty heavy limitations. It necessitated some high privileges, so write the ACL, and most importantly, it could not be used against what we call in Active Directory protected objects that has the admin count equal to 1 LDAP attributes, because for these objects, ACL inheritance from the parent container is disabled. So GP link poisoning is pretty interesting because it can be exploited with very limited privileges over the organizational unit. You only need to be able to write the GP link attribute, and it also works for privileged objects such as domain admins, right? So how does it work? What is precisely this attack? So what you do is that you modify the GP link attribute in order, as I said, to inject an additional GPO link to the OU. And as you can see here, your injected item will not point to the domain, but to a domain name that resolves to your machine. Here, I added a GP link item that points to attacker.cop.com instead of cop.com. And when the objects are fetching the GPOs they should apply because they are linked to their OUs, they will try to apply this GPO, and then the attacker should only simulate a group policy container, simulate a group policy template, and just execute malicious configurations through this injected GPO. So we created a tool that we called UNED to automate the attack. It is available on GitHub. We also added 2 edges to Bloodhound, so the write GP link and generic write edges on organizational units because they are exploitable through the attack vector I just described. All right, let's just describe it more visually. So first, you have a user that can modify, that can write the GP link of an OU, right? First step. Then you poison the GP link. You add an item to the GP link. Third, your object will try to fetch their group policy container on your machine. You simulate a group policy container. And finally, fourth, the object will also try to fetch the group policy template on your machine. You simulate a group policy template, and they apply your malicious configurations. All right, let's have the last demonstration of the session with the UNED tool. All right. So we have a domain here. All right, does it work? I mean, it's weird. Right, just a second. Okay, so we have our domain. We have the PKI servers, organizational unit, that contains a computer that is called AD01 PKI. So we'll try to, so on this PKI servers organizational unit, we have a user that we dubbed N. Augustine that will have some limited rights. she will only have the rights that is called managed GP link, which allows her to, as you can see here, manage group policy links on this OU. And so we'll assume that we compromise the N. Augustine user and we'll try to abuse this privilege she has on the orchestral unit of PKI servers. All right, so we'll try to exploit it in order to add the N. Augustine user to the local admin group of the PKI server AD01 PKI. So you can see here first, the PKI server's orchestral units only has one GP link, legitimate GPO. All right, and the N. Augustine user is not a local admin of the AD01 PKI computer. As you can see here, access denied. All right, so let's exploit this privilege with unet. Unet takes a config.ini file that specifies some configurations. There are a bunch of them, but most importantly, you specify the target orchestral unit. You specify the user that has the right to modify the GP-link attribute, and you specify the command you want to run on child objects. As you can see here, I'm adding the N. Augustine user to the local admin group of my target. There are a bunch of other configurations that doesn't matter. We are spinning off a fake DC in order to simulate a group policy container, but I won't go into details here. All right, so let's execute unet with this configuration. And you can see that there are a bunch of things that unet does. It sets up port forwarding to simulate a GPC. Doesn't matter. The most important thing is that it adds a GP-link attribute into the orchestral unit. As you can see here, if I do some LDIP, I have another GP-link that was added here that points to unet.cop.com, right? And unet.cop.com points to my machine. And so what happens is what I described earlier. The objects will try to apply the GPO by thinking that I am the LDAP server, and I will simulate a group policy container. So on the right, on the AD01 PKI server, I will just execute a GPO update command. And as soon as I do that, you can see on the left, on the unet side, that I will have a communication from the AD01 PKI server that tries to authenticate to me, first to fetch the GPC, so the LDAP part, and I will answer to the computer, and then for the GPT, the group policy template, and I will again authenticate it and respond with the appropriate files. And finally, we can see that the attack worked because the N. Augustine user is now local admin of the AD01 PKI computer. As you can see, I'm connecting to the $C share, and I am local admin of this computer. So we abused this GP-link write permission. Right. Thanks. All right, just a few words to conclude. So we believe that risks associated with GPOs are pretty much underestimated today. GPOs are very powerful just for enumeration, as Wilfried showed you, but also for exploitation primitives. There are a lot of exploitation primitives on GPOs, but also on orchestral units. And of course, we aim to provide a better understanding of how GPOs work, how you can enumerate stuff from them, how you can exploit objects from them. And GPOs are just fun, and don't hesitate to research on it. Thank you.